Happy Martin Luther King Day, everybody. We are moving on to rhombuses and squares. So if you want to find your notes, I'll say that, I suppose. That'd be a good thing to do. Okay, here we go. So kind of like rectangles, we're going to talk about some properties that make a rhombus a square, that make a parallelogram a rhombus and a square. And then you're going to just find missing angles and sides, okay? So we're first going to talk about a rhombus. Back with this little concept map here. So again, a quadrilateral is just a four-sided shape, right? And then from that, we have non-parallelograms, which we'll talk about in our next lesson. And then we've been talking about parallelograms for a while, right? So from parallelograms, we have kind of two different categories. We have rectangles, which we talked about in our last lesson, and then rhombuses. So a rhombus has all six properties of a parallelogram, plus some that make it its own. So, what are those properties? Well, let me tell you. The first one is all four of your sides are congruent. So that's the big one. All four sides of your rhombus are the same. So if this was 5, I'm going to scoot this up a tish here. There we go. All four of those sides are the same. The diagonals are perpendicular, and hopefully by now we know that perpendicular means they form right angles. So all of those angles in there are 90. And then your diagonals bisect angles. This is kind of a cool property. So that means our diagonals are cutting our corner big angles in half. So like if this was, 30, then this half over here has to be 30. And then since it's still a parallelogram, we know that opposite angles are equal. So then we know that this guy would be 30 and this one's 30. You know, the ones in the middle are 90 because your diagonals are perpendicular. And then it's pretty easy now to find the missing one. 180 subtract 90 minus 30 would give us 60. So really, folks, you're only ever going to have 3 different angle measures in a rhombus. And the nice thing is you always know the middle's 90. Okay? So to recap, what makes a rhombus, all sides are the same. So again, like 5, 5, 5, and 5. Your diagonals are perpendicular, so we get those right angles in the middle. And then lastly, your diagonals also bisect your corner angles. Okay, let's try some examples of these. So let's see what we are given here. It says JK is 12 and JN is 7. And we are looking now for these 4 missing lengths. So JM is just a side, and we know all sides are equal, so that's another 12. JL would be this whole diagonal, and remember your diagonals are bisected, so if this half is 7, over here is 7, for a total of 14. MN, I know you want to say 7. It's just not that easy. We don't know what it is, but luckily we can find it. Since we know it's a rhombus, this is a right angle. And now do you guys see how we have a right triangle here? So we just have a little Pythagorean theorem on our hands. Not too bad here. So we'll have x squared plus 7 squared equals 12 squared. Remember, your hypotenuse is the one across from that right angle. Crunch out these numbers. 7 squared we know is 49. 12 squared is 144. Subtract over. We get 95. Square root of 95. We should get x equals 9.7. So MN is 9.7. And then if we want to find that whole diagonal, we simply just double 9.7. 9.7 plus 9.7 should give us 19.4. Woo! So really, kids, the hardest thing you're going to come across with finding a side length is that Pythagorean theorem. But I think we're all pretty rock solid on that by now. Okay. Another one. Here we go. EF is 23. DF, this whole thing is 40. So we'll split it in half to make our lives easier and see what happens there. Okay, GF is just a side, so it's the same as EF, so it's a 23. HF, we already labeled as 20 because it's half our diagonal, which was 40. GH, again, now we have a Pythagorean theorem problem. We're missing this, but we have a nice right angle there, so we can perform the Pythagorean theorem. So we'll have x squared plus 20 squared equals 23 squared. I need to remember 23 squared is 529. Subtract over that 400, we should get 129. Square root of 129, kiddos, is 11.4. Beautiful. And now lastly, GE is that whole diagonal. Again, so if half of it's 11.4, we simply double it, so we get 22.8. Okay. Now let's try work with those angles in a rhombus. So we are given 38 down here, and we have to find all the missing ones. Very simple, easy to do. I think you guys will enjoy this. It's just like a big puzzle. Let's just think, what else would be 38? Well, 4 would be 38 because of alternate interior. We love that. And then we also know that by that property, that the diagonals cut our corner angles in half, that if this half is 38, so is 3. And then if 3 is 38, we know 5 is by alternate interior, or you could use that same property that this angle's bisected, so those have to be the same. We also know in a rhombus that our diagonals are perpendicular, so all 4 of those angles in the middle are 90, which makes solving for these missing 4 quite simple. If I wanted to find 6, we just simply take 180 minus 90 minus 38, and we should get 52. And then again, alternate interior angles tells me 1 is 52. And then since our corner angles are bisected, 7 is also 52, as is 2. Again, you shouldn't get any more than 3 different angle measures in a rhombus, so that's what's kind of nice, okay? All right, let's shimmy on to squares. So again, it's another kind of parallelogram that we're going to learn about. So if we look at our awesome concept map again, again, 4-sided shape. And then it stems from a parallelogram. And from our parallelograms, we have rectangles and rhombuses. And then it's like if you had a rectangle and a rhombus and you mashed it together, you would get a square. So it's like they had a baby and out came a square. So a square has all the properties of a parallelogram, all the properties of a rectangle, and all the properties of a rhombus. And then that's how you get a square. So if we look here in our notes, these properties here come from a parallelogram. Opposite sides are congruent. They're parallel. Opposite angles are congruent. Angles on top of each other add to 180, and diagonals bisect each other. Our 4 corner angles are right because we get that property from a rectangle, and our diagonals are congruent, also from a rectangle. And these last 3 properties are from a rhombus. All 4 sides are congruent. Our diagonals are perpendicular, and our diagonals bisect opposite angles. So if we just use this generic square here, folks, I know I just rattled off a lot of words, but you can read those on your own. Anywho, okay. All of your sides are the same. So if this is 10, these are all 10. Pretty basic. I think you guys knew that in the square. But what's nice now is you only have 2 different kind of angle measures. We have 90s in the middle because our diagonals are perpendicular. And then these corner angles are 90, but we're cutting them in half. So 90 divided by 2 is 45. So all of these angles over here in the corners are just simply 45s. It doesn't matter if you have a really big square or a small one, your angle measures are always going to be this. Always, always, always. Let's try a few examples here, kids. It says if ABCD is a square and AD is 11, Find each missing value. Okay, BC is just another side, so it's also 11. AC is a diagonal here, so we can find that quite simply. If I put 11 here, do you guys see how we have a big right triangle? So we could say 11 squared plus 11 squared equals x squared. 11 squared is 121. 121 plus 121 is 242. Square root of 242. I don't know that one off the top of my head. My notes aren't there. 15.56, so we can say approximately 15.6. So that's AC. BD would be the same because it's just our other diagonal, and we know they are equal. And then EC would be half that amount. So 7.8. All right, now we're just looking for these specific angles. Angle DAB. DAB is that whole corner angle, which we know is 90. Angle AEB. AEB is in the middle, which we know is another 90. Angle CBD. CBD is just half, so 45. And BAC. BAC is another half, so 45. Honestly, the hardest part of that was just tracing out those angles, but we already knew it was going to be either 90 or 45, right? Okay, one more, folks. It says solve for x given the square. Well, we know that this angle has to equal 45, right? So that expression, set it equal to 45. Subtract over your 3. We get 42. Divide out, we get 6. That's all she wrote, I think. Yep. Okay. Thank you for watching and listening and taking notes. Have a super day, and I will see you next time in class. Okay. Toodaloo.